Okay, part two. Same set of data. Now we're going to use some technology and see what happens. Could use a TI-83 or an 84 or another graphing calculator. You could go online, and there are lots of regression tools online. Here's one of them. You do need to look at the data first to make sure that it's linear, otherwise the linear regression wouldn't work. So there are all sorts of regressions here. That's an exponential, that's a power, which could be any exponent, like a 2 or 3 or 4 or 5. And there's some more, but let's see what we have. So here's the data. You just enter it in, hit calculate, and there you go. And so apparently the equation we're supposed to be using is y equals 4.764, blah, 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 10 to the negative first. That means that this decimal needs to move over here. So this is actually 0.4. And then there's the intercept. The other nice thing here is that it gives you a table below, right here. This is the data, so 65, 68. That's the calculated y value, often called the predicted y value. So questions that ask you what height would the son have if the father's height was. A lot of these are already given for you, and it gives you an error here. And if you remember back to what I said, the linear regression line is based on errors between the predicted and the actual value, and these are over here. So these are like vertical distances, the vertical distance between the predicted line and the observed or the actual values that we use to measure. Okay, so let's go back to the other screen. And what did they say? So they said that y should be, and I'm going to move the decimal, 0.476 x plus 35.82. The y is the son's height, and the x is the father's. Plus 35.82. Okay, does that make sense, by the way, 35.82? I mean, when you're born, you should have a height. So that makes sense to have a positive y-intercept. Doesn't always have to occur that way, okay? So even if it was a negative, doesn't mean that the line doesn't fit. But, you know, if you're looking at this, the slope means the taller the father is, the taller the son probably is going to be. So that seems to be working here, and this gives you an idea of where it starts. Use the line of best fit to predict the son's height if the father is 65. So at 65, you should be 66.78. So 66.78. How about 81? Well, that's not in the table because look, 71 is the max, 81 isn't in there. So we would do 0.476 times 81 plus 35.82, and that would give you a predicted height of 74.36. Compare the two lines of best fit. What do you see? So let me find the other one, and I'll write it in red. So the other one was son's height, the one we did by hand, and the slope was 0.714 times the father's height. So we'll just cheat a little, plus 19.304. Well, slope is different, and intercept is different. So in this case, actually, both of these are different. Looking at the predictions a little bit, so 65, we get 66.78, which is really close here. And on the first try, when we predicted it, we ended up with 65.7. And comparing that to 68, you can see it's a bigger error. So most of the time, the line you find is not going to be the right line. Interpret the slope. Well, that's a fairly standard answer that you just have to learn the format for. So let's see, the slope is 0.476. Okay. Put that over 1. Keep in mind that this is a y value, so this was based on the y's, and this one is based on the x's. So, son's height goes in the top, or goes with the top number, so this is the son, and this is the father. And then the sentence looks a little bit like this. It says, for every 1 inch increase in father's height, the son's height increases by 0.476 inches. And we're going to hedge our bets a little bit and say on average. And then the last part is, what do you think is more accurate, 65 or 81? Okay, so 62 to 71, and then we made a prediction around 65. So that one should probably work, because it's right in the data range that we have. And 81 is way down here. So if you have to pick, you should really say this is the one that's more accurate. It fits within the data set, so the prediction should probably come out. 81 does not work. By the way, 81 is 6 foot 9 inches. That's how tall I am. And you can see that the sun's height isn't anywhere near it. All right? Thanks.